Hello and welcome everyone to the Devo Team A Cloud Loft. Today we want to talk about containerization and orchestration. About myself, a couple of words. I almost worked a decade in IT, in multiple industries, definitely in IoT, finance, and insurance. I would say my personal core is about multi-cloud architecture for AWS, for Azure, and on-premise. My main skills are security. We're talking about not only security in that typical way with security groups, for example, or network protection. It's all about nowadays some 4I principles, how we can achieve this. And this goes for me hand in hand with infrastructure as code. Therefore, this is like a huge topic for me personally to understand actually what is the need nowadays in the industry, and it's a very important one. Also, I would say also where I started is with Linux and therefore also with automation with Ansible, for example, so application automation. I'm right now an expert director here at Devo Team A Cloud. Yeah, so for example, for you to understand, it's like a tech lead, team lead. So, what are we talking about today? Definitely not containers. I will just like set this as some kind of pre-requirement because I think containers are mandatory already or as some kind of pre-requirement for this talk to actually understand. We're not building any containers from scratch or something like that, but we're building a huge environment to actually orchestrate those containers. Maybe a funny fact, or not really a funny fact, but a very interesting fact, is that Kubernetes actually deprecated in version 1.21 the Docker container runtime and just changed it with containerd. It's a very interesting one, but is a huge step, I guess, in standardization. From my standpoint, so what is my container history, I would call it. I started in 2014 with Docker and also with Docker Compose to actually deploy small environments for the customer, but it's really not like a you can consider this like a production environment nowadays. It's just like playing with Docker files and Docker containers, and it's really far from production. Therefore, um, everything moved into some kind of different direction. When we had Docker containers, we wanted to orchestrate them in a very standardized way. We started personally with Rancher, and it worked. It was visually appealing, but it was quite hard to actually uh, pipeline or just give it some kind of or just track it in code. And but all of this changed in the later versions. But we just switched to Spray. This is the symbol you can see over here. So from 2015 to 2016, everything was about, for me at least, Rancher and Spray. And over the past years, um, I'm still working with Rancher. I think it's a nice tool to also make it visually appealing to know what is deployed. I mean, there are a lot of integrations. If you, for example, have some kind of multi-cloud environments, I think it's a very nice and interesting tool, definitely. And also with version 2.0 or .x, it really got improved by a lot. But if you think about deploying your orchestration solution in the cloud, we first worked with COPS, but to be honest, I think you need to trust the cloud provider you're working on. Therefore, on Azure you have AKS, and on AWS you have EKS. So this is like a major step also in terms of standardization. You know the toolings, it's all built into the cloud already. You just need to use it. And also in terms of cost, it also reduces your cost by a lot if you think about your master nodes and all of that kind. So, what will we do today? I prepared some kind of architecture for you. First of all, here in a written form, how this kind of loft presentation will look like. So we will work first of all with Terraform. to actually provision the network setup, the EKS cluster, the managed worker nodes, Fargate profiles, and also the policy for our elastic load balancer. And we will just continue then afterwards with AWS CLI and EKS CTL to actually manage the whole environment, the EKS in general, get our kube config and stuff like that. I just want to make it very easy for you to understand different kinds of how you can manage your cluster, your components. And therefore, we also have a third component, which is about Helm and Argo CD. This is our application, our container way, or our way of how we want to deploy our containers. In a visual form, this looks like this. It's just about like we have the VPC. Okay, those managed worker nodes are also in that kind of subnet. But what was interesting for me to actually state here is that we have Argo CD in a way running here, that we have it on the EKS managed node groups, and the application Argo CD is deploying is running on AWS Fargate. So this is just interesting because I just wanted to point it out here that we are also deploying on two different kind of work pools. If you want to follow this course directly, you can just copy paste this into your browser, or just go with the short link, or take your smartphone and just scan the QR code. And we will just quickly shift now to our code editor. So we are now in our code editor. As you can see, we have our README MD file here. It explains all the steps we're doing. So you can also just like pause the video, or do it in parallel, or do it just like afterwards. Everything is documented. And that should also give you some guidance if you want to do this on your own, or just like grab a couple of code snippets and copy paste them to your environment if you think this is like helpful for you. But in general, I just want to show you some kind of navigation. So we have the Terraform directory, we have the Argo CD directory for our Argo CD deployment, and later on for our application deployment, we have the game directory. What we have done already is deploying all of this infrastructure components. It took like 16 minutes to completely deploy the VPC, the EKS cluster, the worker nodes with it, the managed worker nodes with it, and the Fargate profile as well. And everything is already done here, so you don't need to do anything else. We now just need to follow this kind of documentation. As you can see here, also the Terraform step is documented, and everyone should be very familiar with this if you ever worked with Terraform. So that should really be a very easy one for you. What I've done here is just like set some environment variables to just ease this kind of installation guide and make sure everyone can follow. So what we will do here is just like set an environment variable for your EKS cluster, and do the same for the region. This is, I think, a more general one, because you also need to preset your environment variables for your AWS credentials, but I did this already beforehand. We will now get the kube config from EKS, so from our AWS environment. We will just use the AWS CLI to actually get the kube config. And if it looks like that, it definitely worked. What we can do now to see if it worked, just get the nodes and see there we have our managed worker nodes over here in version, and that's perfect for now. What we now want to do now is to get the AWS account ID, and we can do it in a very similar way by just exporting again AWS account ID this is important for the next step when we're working with EKSCTL. This is mainly I would call it, yeah, a wrapper. Sorry for that. A wrapper around like a couple of different AWS mechanisms, but it's mainly just like CloudFormation templates. But you can just dig all of those commands which are used or which are done with EKSCTL. You can just look them up and see what's behind them. That's not really a big issue, and therefore you can also Terraform all of them. Important for you, we'll just quickly send this command. Here is the AWS account ID, and here's again the cluster name to just make sure it works for everyone. This is like done in a very simple way. But what we're doing here right now is we are creating the IAM service account. So this is basically the connection between the AWS part and the Kubernetes cluster in general. And this combines and allows the Kubernetes cluster to talk to the AWS API. In the next step, we will verify this. So if this command is done and it's done over here, we see created service account, everything worked. We can just verify if that worked also in our Kubernetes cluster, and it does. That's good to know, and always interesting to actually go step by step, make sure everything is working, because then later on you don't have any other problems with it. What we need here is the cluster VPC ID. We will do this the same way as we did this the last times. And what we are actually doing, we are adding a Helm repository into here. So this is important and the pre-requirement for the next step. Let's just copy paste it. I have done this already a couple of times. I think you guessed it already. And we will install the ingress, the AWS load balancer controller ingress, which is then automatically creating, if there is some kind of ingress requested in the cluster, some kind of external load balancer directly in AWS. So this is like a huge benefit and reduces maintenance efforts and definitely also increases control. So we will deploy this with Helm now. And over here we can see again EKS cluster name, EPC ID. So this step over here is definitely a pre-requirement. We can verify this again, but we are doing this in a similar way, just like finding out, because there are a couple of resources in the kube namespace, kube system namespace, and we want to find this out with the label. So we just take this one and copy paste it. And we can see we have the top pods deployed over here. We have the deployment over here. That's great. So everything is working and we can just move on. So we have our ingress now. That's perfect. It's deployed there. Okay. But now we're talking about the application, what we want to deploy and how we want to deploy. And then at this point, Argo CD is kicking in because we will just quickly install it. So we'll create a namespace for Argo CD and we will create, or we will install it over here with this command. Behind that command, it's very simple. I will just show you. We have like, I don't know how many hundreds of lines over here, but there's a lot with, oh, we have an arrow over here. Just make sure that you're in the right directory and not running it from subdirectories. So this should work now. And as you can see over here, there are like plenty of services which are getting created and yeah, just like objects and whatever. But Argo CD is really like the cluster manager now, and therefore it's like deeply connected to almost everything. But you can also run, if this is ever getting outdated, you can also run this command over here, which is in the file, in the install YAML, which is directly connected to the Argo project, and then everything should be stable and also working. Now, what do we have? We have installed Argo CD, with our kubectl file. We will make sure that everything is working right now. The server is still not up and running, but we can make sure with the -w to actually track what is going on there, and let's see how long that takes. It should take a minute or two in general if we have like everything together, but the server is definitely the most important part. It's up and running, and it took like 60 seconds. That's really fast. Perfect. What we want to do now, because we already verified it here with this step, we want to get the secret, because Argo CD is not printing any secret or whatever. It just creates a secret internally in the Kubernetes cluster, and therefore we want to get the secret over here. This is like basic printing out some kind of secrets over here, decrypt it or decode it more or less, and then just like echo it to the terminal. Now we have the secret. Most important for me was that we have a really simple way of how we can deliver some kind of results in that kind of time we have for this talk. And therefore, I thought, okay, we won't create an internal ingress and we won't create some kind of VPN connection, whatever. I just want to have it simple. And therefore, we will just port forward to the actual service. And this will do like a forwarding of the service Argo CD server. On our local machine, it's 8080, and we're forwarding to the service on 443. Very important, I have created another terminal to actually work with it in the first place. You also make sure you have your AWS credentials configured here, otherwise it could maybe not work. But you have your kubeconfig already locally, so it could work definitely. So what do we do here? We just paste this in here, and if we see like forwarding successful on that one, we can verify this. So we could either just like go in the browser, let's check, copy it again, go into the browser and just like go on localhost 8080. Okay, we get this self-signed certificate issue, but we can just skip it. We can go here in admin, copy paste the password and sign in. And it worked. We have a clean environment over here. We have no repositories, we have no application. And that's a very simple way to actually connect to your application. I wouldn't say it's like production ready. And also if multiple people connect to it, you should not use it. But in that kind of dev environment where what we're creating over here, it's definitely fine. We can also connect to it with the Argo CD CTL, basically, our command line tool. And therefore we just say login. Yes, we trust the self-signed certificate. Username is admin again. We have our secret over here. So admin secret, and if it's like successfully updated, perfect, we're done here. We can now create a repository inside Argo CD, and you can do this either manually, do this with Terraform as well, or just do it with the Argo CD CLI tool. And this is basically like just a connection for our deployment, what we have in the next step. So we will create a repository over here, and it's like lightning fast. You can't create it that fast if you just do it manually. Important step is over here, connection status. It should be successful. If it's not, you definitely have some kind of security group issue or something. Some kind of outgoing traffic is not allowed, and therefore make sure it's that it is successful. But if you just use my configuration, it's working. Security groups are configured to work for managed worker nodes, and it also works for Fargate, definitely. But yeah, we have Argo CD running on the worker nodes, managed worker nodes. So there's no Fargate yet. We will just jump to the next point where we actually deploy the application. What we want to see then exposed with the ingress and deployed with Argo CD. So we will do this with the interface just to show you like how you can do it. Just copy paste it in here and we click on save, but we're not done yet. We still need to create it, but everything so far is pre-filled. It's relatively easy. And we have our repository here to actually get the code from there. So we have our Git repository and we have the path game. And therefore, it's super easy because Argo CD technically just looks in the directory and search in the searching for those kubectl files and is then creating all of its resources. So let's see what happens. That's looking good. We are in progress and we see we already have like our namespace over here. Service deployment is starting. Everything so far is really looking good. Interesting point here. You can also, if you push some kind of new commit to the master branch, Argo CD will make sure and is synchronizing with that repository that everything in the repository is also on your environment, which is connected to that kind of repository. Therefore, it's like super interesting to actually, yeah, use it for bigger environments where you want to have visibility and everything else. But why does it take so long? So we can verify this with this command and see it's still not working. It's still in pending mode. But now, okay, it took that long because Fargate takes a while, not really a while, but a couple of seconds to actually yeah, allocate some kind of node or where it is deploying to. And then therefore it's not really meant for like super quick startups and just like yeah, just like very quick applications where you just start up and a couple of seconds later on you just delete it again. But I think for applications which run for a couple of minutes or hours, it's perfect because you don't have some kind of node shifting in your cluster, and you can just like have some extra workloads which are running for, I don't know, 20, 30 minutes, just spawn Fargate, do your application in there, and that should be completely fine. Now it should be up and running, but you can just spot your Fargate nodes with the prefix Fargate in terms of the other nodes. Just want to make sure everyone knows what I'm talking about. We have other nodes with this kind of, yeah, naming schema, and we have Fargate over here, which is definitely here prefix with Fargate. That's great. Let's clean it up, and we just want to make sure we also have some kind of ingress now running. This is like super interesting because you're not like getting some kind of weird internal ingress address and need to translate it somehow. You directly get the external load balancer address of, yeah, the load balance actually. We can verify this in our CLI over here. And yes, it's active. It's up and running here. And we can make sure or just verify if it's working. Let's go to the address. Let's give it a second or two. And as we can see, Chrome nowadays blocks 80 so unprotected connections. So we just need to continue over here, and we see the game is actually running, up and running, and that in a very fast way. And what we've done to create a load balancer, actually nothing. EKS took care of the whole connection between AWS and the Kubernetes environment and made sure that, yeah, it is connected, it is authenticated, and yeah, to create a load balancer. What we're doing now is cleaning up all of this. There are a couple of ways. We're doing it just like that. Delete in Argo CD the game, and we can make sure also that it is deleted in the UI. So we will just switch to the UI. It's already saying missing over here, and I think in a couple of seconds it should be gone. Just refresh. let's see. The important step over here is to actually delete it, because if you don't delete it, the load balancer is not getting deleted, and then if you destroy the Terraform code, it's it doesn't know about the load balancer, and therefore you have like extra cost running. That's, I wouldn't say, the best way, and therefore I'm also showing you how to delete it. Today it takes a while, but I think it's still deleting. It's deleting the namespace, and you can directly see what it is going for. And it was successfully deleted. This shows me the green bar at the bottom. We will also delete the repository. It's not necessary to do that because it's not creating any load balancer. But what is very important is also to delete the CloudFormation template. I just want to show you that you also can see what is happening there. So we have here this CloudFormation template, and you can also configure it like a normal CloudFormation template. We just should delete it. So we have a clean environment again, and it's deleted as well over here, deleting in progress. And what we will do in the last step, go into Terraform, destroy, and we should have 67 resources to destroy. And if that's the case, we can just destroy it and move on again to the presentation. So how do we continue now? Everything on the right side over here you've seen today. Terraform to deploy all the necessary resources like VPC, the EKS cluster, the worker nodes, the Fargate profile, and everything is in Terraform nowadays. And we have Argo CD to deploy our application and manage the whole EKS cluster on the Kubernetes level. So we don't need anything else besides that, because also Argo CD can also deploy Helm charts and like manage the whole Kubernetes cluster. And therefore you always have good visibility. You can always synchronize with your repository, therefore have your whole code, which is getting deployed on your Kubernetes cluster inside a GitHub repository or a Git repository in any way, and synchronize it continuously and make sure everything what you want to have on the cluster is on the cluster, and everything else is just getting removed. But in the next step, I think it's very, very important also to mention that there is still like an improvement on that end. So what you want now to do is to manage your Terraform with the 4i principle. And what is that? Maybe you don't know that kind of product. It's Atlantis. It's an open source project. And personally, I think it's really amazing in terms of Terraform, managing Terraforms with teams. And it works for GitHub, it works for Atlassian Bitbucket, for GitLab, everything. So you can just simply integrate it. It's like one container which is managing like your whole Terraform, and you configure it with a master repository for, in general, like who is allowed to do what, and also what kind of repositories you want to have connected. And in that direction, I just want to show you how it's working, just as a future step, maybe for you as a vision to integrate this into your environment. So we have the Atlantis workflow, we have some kind of code changes, in this case null resource demo, and we just have this code change in a pull request. Next step, Atlantis. If you push this to your repository, Atlantis will show this kind of output. It will plan it and say, okay, we will just add one additional resource, the null resource demo, and you now can basically approve this pull request. So this guy, Alice, approved it, and now we can apply it. So it's like not Terraform apply anymore. It's just like Atlantis apply. You don't need the local CLI installed. Whatever Terraform scripts you use, it's just like Atlantis is taking care of everything. And therefore you just like Atlantis apply, then Terraform apply is running. It's even deleting the branch after everything has been merged successfully. And if not, it's just like throws an arrow, oh, something hasn't worked out that well, please fix it. But if you just think about like a whole working process, and what we had so far this day, it's really, really important to think of that like a whole management system. If you set up Terraform for a bigger organization, this is definitely the way to go. And with that, I just want to leave and say, okay, now it's time to ask questions and whatever floats your boat, basically. Thanks for your attention.